Hey guys, welcome to Unit 13. This is the day that we start our conics and polar equations. We're going to look at conic sections and first, and today we're going to talk about circles. So what are conic sections? Why are they called conic sections? Um, the ones that we need to focus on are circles, ellipses, and hyperbolas. So we're going to spend the next few days kind of talking about each one of those a little bit in detail. We're going to start with a circle, and so how you come up with a circle is you look at a cone, and if you were to, um, like a plane were to go through that cone horizontally parallel to the base, that would create a circle. You don't need to worry about parabolas. An ellipse is formed on a cone when you intersect the sides anywhere except parallel to the base, and it doesn't go all the way down to the base. And then a hyperbola is the other conic we're going to look at, is when you intersect two cones vertically, perpendicular to the base. And so this is how these are formed and how those shapes are created. You will need to know these. I'll talk about these more later as well. I just kind of threw this into this slide since we're introducing conic sections. So this is our equation for the circle: x minus h squared plus y minus k squared equals r squared. So r stands for our radius here, and h and k would be the center of our circle. So looking at this particular problem, I'm just asked to find the center and the radius of the circle. I need to identify h and k, which h is paired with x and k is paired with y. We've always talked about h being opposite and k not being opposite. Here k is going to be opposite just like h is. They're both inside parentheses with their variables. So our center is going to be 7, negative 2 of the circle. And then our r squared is 225, but I want to know what the radius is. So I need to take the square root of 225, and that would give me a radius of 15. Okay, let's look at writing an equation of the circle, and now we're given the center and we're given the radius. So if I'm given a radius of square roots of 15, we need to write r squared. We need to write our radius squared. And then I also can fill in 0 and 3 for my h and k. If I do x minus 0, that's just x. So I end up with x squared. If I plug in a positive 3 for the x minus k, that gives me y minus 3 squared. And then if I square my radius of square root of 15, because that is equal to r squared, that would just give me 15. Okay, find the center and radius of the circle. This equation of the circle is not in standard form, as we saw originally. That is unfortunate. So, on the back of your notes, if you will turn with me, we're going to talk about how to write this in standard form of a circle. And this involves completing the square, something you learned about in Algebra 2. And it's a method used to transform a quadratic equation of this form into a perfect square trinomial. So in other words, when you complete the square, you adjust the equation so that one side becomes a square of a binomial. So like this x minus h squared is what we're going to do. So we're forcing this to happen. It doesn't happen naturally. We're making this happen. So here's some examples of some perfect square trinomials. Why are they perfect square trinomials? Because they can factor like this. So x squared plus 4x plus 2. And we can think about this. We can go through any method that we want to factor this. It's best if you can recognize the patterns here. But we have done those shortcuts where we said if a is 1, we can start off by writing at least this. And then these two numbers right here have to multiply to this and add to that. So there's only two possibilities, which is the x plus 2 times x plus 2. We do that, so then we can write this as x plus 2 squared. Okay, let's look at this next one. X squared minus 12x plus 36. This is a perfect square trinomial because negative 6 multiplies to 36 and adds to negative 12. So I can write this as x minus 6 times x minus 6, which then is x minus 6 squared. So our goal is to get it to look like what we have, x plus 2 squared or x minus 6 squared, because that's what our equation of a circle is. It's x minus something squared plus y minus something squared. All right, let's talk about how to complete the square, and we'll look at when a is 1 first. So when a is 1, this is, you're not going to have, well, I mean, you might have an equation like this, but the first thing we want to do is we want to get just our a and b term together, and we want to move anything that does not have a variable in it, our constant term, to the other side. So we're going to move our c value to the other side. And I created these blanks here, and those blanks are helping me to remind I'm about to add something and make this become a perfect square trinomial like the ones that we saw on the previous page. And if I'm adding something that wasn't there before, to keep my equation balanced, I have to add something to both sides, which is why I have a blank on both sides of the equation. So what I'm going to add to make this thing happen is I'm going to add b over 2 squared to both sides. So my b value here I have colored in blue. That's negative 10. So if I do negative 10 divided by 2, that's negative 5. And if I square that, that's 25. So I'm going to be adding 25 to this side and 25 to this side. And then I'm going to factor. So I'm going to factor the left side of this equation. Two numbers that multiply to 25 and add to negative 10 would be negative 5. So that would just be x minus 5 times x minus 5. And then I'm going to add negative 14 and 25 to get 11. And then I'm going to rewrite like this. So we can skip some of those steps, and the quicker you can identify these patterns, the better. Here we have ones kind of similar, but I added an a value that's not 1. We have an additional step we have to do. We're going to start off by moving our constant as we did before. But this next step, we need to factor out our a. So I'm going to factor out my a value. So I'm going to divide 3 out of 3x squared and minus 18x. And now I'm going to complete the square by just what's in the parentheses. So I have those blanks here. So now I'm not looking at my b value as negative 18. I'm looking at my b value as negative 6 because I factored that out. Okay, so I'm going to do negative 6 divided by 2, which is negative 3, and I'm going to square that to get positive 9. So what I add to one side, I also add to the other. However, I didn't really add 9. I really added 27 because this 3 distributes to all of these things. And so if it distributes to this, I'm really adding 27. So this is kind of the tricky part. When you go to the other side of the equation, you need to make sure that you add 27 and not just 9, because that's going to throw off our whole equation. Then we're going to factor this. I'm going to keep the 3. The 3 is going to come down for the ride. It's just going to be in front of everything. Two numbers that multiply to positive 9 and add to negative 6 would be minus 3 and minus 3. These should be the same numbers. That's what we're doing to make a perfect square trinomial. If I add negative 14 and 27, I get 13. I'm going to rewrite this as a binomial squared. So I get this. Okay, so now let's see if we can figure out how to do that with this equation, because that's precisely what we're going to do. And so we're going to complete the square, but first we are going to, I'm going to move my constant. And then once I move my constant, I'm going to group my x's together and my y's together. So I have an x squared and a 4x and a y squared and a 2y. I'm going to write those together, and I'm going to complete the square for both of these guys. And I have a blank for both of them. So my a value is 1 in front of my x squared and my y squared. So I don't have to worry about factoring out my a value. But now I'm going to add b over 2 squared to both sides. So looking at my x's, that would be 4 divided by 2, which is 2. Squaring that is just 4. So I'm going to add 4 over here, and I'm also going to add 4 over here. Then I'm going to do the same thing for y. 2 divided by 2 is 1. 1 squared is 1. So I'm going to add 1 to this side, 1 to this side. X squared plus 4x plus 4 is x plus 2 squared, and then y squared plus 2y plus 1 is y plus 1 squared. And if I add 4 plus 1 on the right side of the equal sign, that gives me 9. Writing this all out, I get something like this, and now I can see where my center is. It's at negative 2, negative 1, and my radius squared is 9, so therefore my radius is 3. All right, find the center and radius of the circle. I could have sworn we've already done that. Oh, okay, never mind. All right, so y'all's delta math that goes along with this are the following sections, these first 5. So good luck. Make sure you ask questions as you have them.